Okay, Vandana. So I
Mm.
wish you a very good afternoon, and I hope you're able to hear me and there are no glitches, Vandana, right? From your side.
Yes. Yeah.
All right,
Good
fantastic.
afternoon. Yeah.
Very
Mm.
good afternoon. And we are not going to go into the introductory part or, that we have done in our previous video, Vandana, because right by now, I think our
Mm.
audience and our viewers mostly know about us and they'll be
Mm.
mostly interested in the problem statement rather than listening to
Mm.
us, right? So
Mm.
let's quickly
Yes.
jump onto the problem. And
Mm.
please confirm, Vandana, that if you are able to see my
Okay.
screen.
Yes, sir. It's
All right.
visible now. Yeah.
Fantastic. Thank you so much for
Mm.
confirming. So today's problem
Mm.
that we are going to do, Vandana, is plus one problem. Okay, it's a very, if you think about the problem, if you
Mm.
read, let us read through the problem to understand what it
Mm.
is. It's a very simple
Mm.
problem, okay,
Mm.
to solve. And these kind of problems are very important from an interview perspective because this doesn't follow a specific, logical pattern or pattern recognition.
Mm.
This is that
Mm.
if you remember the pattern or you know the pattern, you'll be able to solve it during the interview. But this actually tests your
Mm.
logical thinking. How, if you can
Mm.
think logically during an interview process or whenever you code, how strong is your logical
Mm.
capability, right? So
Okay.
this problem is very straightforward. You are given a large integer and the integer is represented in the form of integer array. So example, if you have 99,
Okay.
it's represented like 9 comma 9. Okay. If you have
Mm. Okay.
123 or 131, it is represented as 1 comma 3 comma 1.
3,1.
Clear? All
Okay.
right.
Okay.
And where each digit size is the ith digit of the integer. The digits are ordered from the most significant to the least significant in left to right order. Okay, that means that
Okay.
for 131, your 1 is the most significant digit, and this one at the end
Mm.
is your less significant digit. So if you traverse from left to right, you are traversing from the
Okay.
most significant digit to the less significant digit. Is this clear,
Okay.
Vandana?
Yeah. Yes, sir.
Okay. And this large integer, it does not contain any leading zeros. That means we will not have any integer like 0, 1, 2 or
Mm.
0, 0, 1. No, this is not
Okay.
acceptable.
The
So there
first
are no,
integer should not be 0. Yeah.
there should not be any leading zeros. It should not start with a
Mm.
zero, right? It can end with
Okay,
a
sir.
zero. It can
Huh.
have 102
Mm.
or 120.
Mm.
This is acceptable. This
Mm.
is fine. Completely
Mm.
fine.
Okay.
All right.
Okay.
Is the problem
Okay.
statement clear?
Yes, sir. Yeah, clear.
Vandana? Okay,
Mm.
brilliant. So, what kind of use cases can you think about? Let's say, Vandana, you have 1 to 1. So, when you add 1 to this 1 to 1, what does it become? It becomes 122,
1, 2,
2,
1,
right?
2, 2. Yes,
Correct.
sir.
So, when you add 1, normally in mathematical operation, mathematical addition operation, what do? You do
Mm.
1 to
Mm.
1 and then you add the least
Add.
significant digit here.
Yes, sir. Huh.
Right? So you can
Yeah.
understand that we have to start iterating from the least significant digit,
Least
not from the most
significant.
significant digit. Correct? This
Mm.
much is
Yes, sir.
plain. This much is very,
Yeah,
very
clear.
crystal clear to you, right?
Yes,
Fantastic.
sir. Clear. Mm.
So now, if you imagine that the least significant digit is less
Mm.
than 9, if it is less than 9,
Mm.
then you simply need to
Mm.
add 1 to it, and that should be your answer, right? Let's say you
Mm.
have 121, your out answer is
Mm.
122. If you have
Mm.
122, your answer is 123 because your least significant
123.
digit is 2 here, which is less than 9.
2.
But,
Mm.
and until 8, it should be, if it is 128, it should be 129. That should be your answer.
129.
So one thing you
Yes.
get that if
Mm.
your least significant digit is less than
Less
9, you
than 9.
simply add 1 to that
1,
and you
2.
return
Less
your,
significant. Mm.
yes, and you return your array, right?
Mm.
This is
Yes,
clear?
sir.
But
Mm.
let's come to the next case. Let's say 99 or let's say 129. If it is 129, what happens? This time your least
Mm.
significant digit is not less than
9.
9. It is equal to 9. Whenever
Mm.
it is equal to 9, what should be the output here, Vandana? It should be
Uh,
130.
130. Yes, sir.
Correct? So what is
Mm.
happening? That we are simply replacing this least significant digit with a 0, right?
0.
And
Yeah.
we are adding 1 to this 2, right?
2.
130.
Yes, sir.
Clear?
Mm. Mm.
And
Yes, sir. Clear.
what about Vandana if we have,
Mm.
let's say, 99 as depicted in this example, right? What happens? So this is a new
Yeah, it
observation, right?
100.
And
Mm.
now can you see, Vandana, that your the
Mm.
length of your output array is one more than
Increase.
the length of your input array, right?
Mm.
So to
Yes, sir.
handle this condition, you would need to make all these values 0 and
Mm.
you need to have another resultant array whose length will be 1
Yeah,
greater
that should
than
be
the,
one.
yes, let's say you have
Mm.
you have one more resultant array whose
Mm.
length, and the length of this array should be 3 in this case.
Three. Mm.
This array should be 3 as the length of your input array is 2. Correct? For 99,
Mm.
that is your length input array, right? The length is
Yes,
2.
sir.
But the
Two.
length of the resultant array should be 3, one more, because you have to store 100.
Mm.
And you can
100.
see for these kind of cases where all the digits in the array is
Mm.
9, you are
9.
simply replacing this 9 with all these 9s with zeros. And in
Mm.
the resultant array, your most significant digit is always 1. So can
1.
we say that resultant of 0 will always be 1 for this kind of
Mm.
situations?
Yes, sir.
Okay. So
Mm.
can you find any other observations or any other test cases, Vandana? Any other test cases or
Sir,
any other observations? So what
no,
we
sir, like
saw that if the least significant digit
less
is less
than.
than 9, we simply add 1 to it and we return,
Mm.
right?
Yes,
Now
sir.
what we see? Now the second thing is if the
Equal
least
to.
significant digit is equal to 9, we make
Mm.
that value 0 and we go
Mm.
to the preceding value. Preceding means
Mm.
one before the least significant digit. And we check that whether that
Mm.
is less than 9. If that is less than 9, we add 1 to it and we return the
Mm.
answer, right? For
Mm.
example, in the
Yes,
case
sir.
of 129, that is what we did, right?
Mm.
9
Mm. Yes,
was
sir.
equal to 9. So
Mm.
we made this value 0 in our output, and
Mm.
we simply went to 2 and we saw that okay, 2 is less than 9. So add
1.
1 to
Mm.
it, make it 3, and then
Mm.
you return
3.
130. 1 is intact only. You are not touching 1 for this array.
Yes, sir.
This is your
Mm.
output. And the
Mm.
final use
Mm.
case that we saw was when all the digits are equal to 9. In that case, the
Mm.
output array length will be 1 more than the
1.
input array length. So in
Inputted.
that,
Mm.
yes. And in that case, for example, for 99, we have 100. For 999, we have 1000.
How, sir? Mm.
1000, right? In this
Yes,
case,
sir.
we simply put the most significant digit of this output array to 1 and all other digits will
Mm.
be 0. For example, for 99, you see that if this is our resultant array, the most significant digit here is 1,
1.
right? And everything
Mm.
else is 0. In case of 999 also, it is the same thing, that the most significant
Mm.
digit will be 1 and all other digits will
1.
be replaced by 0. So
0.
these are the three cases that we will mostly handle, and this also includes our edge
Mm.
cases, right? So this is one of the edge
Mm.
case that we
Yes.
talked about, right? This is also
Mm.
one of the edge case
Yes.
that we talked about, right? And this is the plain simple positive scenario that we are talking about, correct?
Mm. Mm.
So can we
Mm.
code this up, Vandana?
Yes. Yes, sir. Yeah.
All right. So what do we do? As I already told you, when we add, we start from the least significant digit, right?
Least.
So
Mm.
our
Yeah.
loop will
For.
start from the length minus one, digits dot length
Mm.
minus one, which is the least significant
Yes.
digit. From the end we'll start. We'll go
Mm.
up till 0, and then
0.
we will
I minus. Yeah.
minus minus. Okay. And what are we going to
Mm.
do? We are going to check whether our digits of I is less than 9 or not. If it is less than 9, what do we
Mm.
do, Vandana? We already spoke about it. We simply add
Mm. Add.
1 to it and we return
Mm.
the value. That's our answer,
Return the value. Yes, sir.
right? Let's say this condition
Mm.
is not satisfied. In the case of 129, what were we doing?
Mm.
We were first
Yes.
making this value 0, the current
Mm.
position value 0, and then we were again going to the next value in the loop. So
Mm.
now 129, 9 so this condition is not satisfied for 129
Yeah.
because
Mm.
digits of 2, for 129 digits of 2, which is
Mm.
9, right?
9.
That
Mm.
is not less than
Equal
9.
to.
So this condition
Mm.
is
Mm.
not satisfied. So this position
Yes, sir.
becomes 0. So instead of
Mm.
129, for the last significant digit, the least significant digit becomes 0. And then again
Mm.
our loop continues. We come to 2 now, right?
Mm. Mm.
Of
Mm.
129
Yes.
now come to the next
2.
digit, which is 2.
Mm.
So now we check
Mm.
that 2 is less than 9. Yes, 2 is less than 9.
Yes.
We simply
Mm.
add 1 to this 2 and then
Mm.
we return the output. So that becomes 130, right?
Mm. Mm.
Correct. Now we have
Yes.
handled the situation where we are having an input array like
Mm.
this.
Mm.
right? We have
Hmm.
not yet handled. In this case, it's very simple. So
Okay.
for when this loop runs, all of these
Hmm.
values become zero because all of these are
Hmm.
equal to 9, right? And
Hmm.
now
Hmm.
we cannot store it in digits. We need to have another array, right?
Yes,
Because
sir.
the length of the new array will have to be one more than the length of the input array, which is
Hmm.
digits.
Input
So
array.
let's
Hmm.
take this result array and let's say that this length is one more than this,
Hmm.
right? And
Yes, sir.
what we do for this, it's plain and simple. We just have to make the most significant digit as 1. We already saw
Hmm.
that, right? And we return
Yes. Yeah.
this.
Hmm.
We return this. So if
Hmm.
this condition is not satisfied, so in this case for 999, this condition will never be satisfied, right? And all of these digits will become 0 here, correct?
Hmm.
Correct? All
Yes.
the nines
Hmm.
will be replaced by 0,
0.
and
Hmm.
we will simply make the most significant digits to digit to
1.
1, right?
Hmm.
Now you can
Yes.
ask me that when we declare an array, by default all the values are 0. So why are we doing
Hmm.
this part for 999?
Hmm.
This we are
Hmm.
not specifically doing it for this test case. We are
Hmm.
writing a logic, generic logic that will
Hmm.
handle any sort of inputs, right?
Hmm.
Because for
Yeah.
123 you have to go with this logic, no?
Hmm.
Otherwise you'll not be
Hmm.
able to do. For 129
Hmm.
you have to run through this logic, and you are
Hmm.
returning even before you are coming to line number 15 here, right? You are
Hmm.
returning the
Yes.
answer here.
Hmm.
So that
Hmm.
logic has to be executed first to make the
Hmm.
entire function generic. Is it clear?
Hmm. Yes, sir. Clear.
Okay, fantastic. Can we run
Hmm.
this code and see what's the
Hmm.
output? So what should be the output here, Vandana? Okay, let's try with a simple thing.
1000.
Let's
Hmm.
try with 1, 2, 3. The output
Hmm.
should be 124.
1 to 4. Yes, sir.
Okay, let's run this and see. See, we get
Hmm.
124,
Hmm.
right? Let's try
Hmm.
with 129, the case that we thought of, right?
Hmm.
What should be the
Hmm.
output here?
120. 130, sir.
Yes, 130. And let's
Hmm.
try with now 999. What should be the output here?
1000. 1000, sir.
1000. So 1, comma 0, comma 0, comma 0
Comma
should be
0,
the
comma
output.
0.
Let's see.
Hmm.
Is it clear?
Hmm.
Are we
Yes,
getting the
sir.
desired output?
Hmm.
Fantastic. What is the time complexity of this code, Vandana?
There should be best and worst cases. So,
Yes. So why best
hmm.
case? Why best case, Vandana?
Best case means like if they have given that 123 example, so input
Uh-huh.
should be 123 means there is no need to run the other part like if
Correct.
uh,
For 123, you are not iterating through the entire array itself, input array
hmm,
itself, right? You are just in the
hmm,
first instance only, you are adding one to
hmm,
it and returning, right? So your
hmm,
base case
hmm,
time complexity is a constant time complexity, right?
hmm, hmm,
Is a constant time complexity which is order of 1, right?
one,
And what is
hmm,
your worst case where you have to iterate through all the digits
all
of the
the
input array.
yes,
So the
hmm,
worst case complexity is O of n, which is
n linear,
linear time, and this is O of n, where
n,
n is the length of the input array.
hmm,
Okay,
hmm,
where n is
n
nothing but the length of the
length
input
of
array.
the input,
Array. Correct? But
yes, sir.
whenever you are asked to tell the time complexity, you should always go by the worst case. It's always good to say the best
Okay.
case also and the worst
Hmm.
case, and then you say that since this is the worst case, so the overall time complexity is going to be
Big of
O of
one. N.
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 So overall time complexity is always your worst case, right? It is big O
Hmm.
of n.
Hmm.
What
N.
is your space complexity here, Vandana? What is your space complexity?
O of 1, sir.
Yes. So we are not use why O of 1? No. You are using this result, right? You are using this array.
Hmm.
So for this
Hmm.
case 999, right? For this case
Hmm.
999, we are using another array, no? Whose length
Hmm.
is one more than the length of
One more
the
than.
input array.
Hmm. Hmm.
So your best case, again, here you will have a best case and worst case, right?
Hmm. Yes, sir.
Because in the best case for 123 or 129, you are not using any extra array or extra
Hmm. Yeah.
space,
Extra space. Hmm.
right? So for
Hmm.
best case complexity, your space
O of.
complexity will also be O of 1.
Hmm.
But your worst case is that example 999, right? where we are actually
Mm.
taking some extra space,
O of n. Mm.
which is this n is
O of n.
basically one
Mm.
more than
Mm.
the length of the
Mm.
input array.
Mm.
Okay, so this is the
Mm.
definition of n here,
Mm.
where n. Okay, you got
Mm.
it?
Yes.
So what is your
Mm.
overall space complexity here, Vandana?
O of n, sir. Worst case only we have to take, no?
Overall space complexity is O of n. And this
Mm.
approach that we saw used to solve the problem
Mm.
is called a test-driven
Mm.
development approach. Why test-driven development? Because first we considered all the test cases, edge cases, and everything, and then we wrote the function which
Mm.
handled all of them, right?
Mm.
But in
Mm.
development,
Yes, sir.
in software development life cycle, we also do the other way around.
Mm.
That is, we first write
Mm.
the function. There are a lot of companies which do that. They first write the function and then they write their test cases, unit test cases or integration test cases to test whether the code is
Mm.
satisfying the criteria or not. Okay.
Mm.
Yeah, this approach that we have
Okay,
followed is a
sir.
test-driven development. We first came up with the test
Mm.
cases and then we wrote the function. And it
Mm.
is always a better approach. This approach helps us in,
Mm.
resolving bugs. Because when you
Mm.
already think about where you can fail, you will already handle that in your,
Mm.
right?
Yes. Yes, sir. Mm.
Awesome. Awesome,
Mm.
Vandana. Also, I want to show you one more, trick.
Mm.
So let me clear this. And if you want to run
Mm.
this problem, just,
Mm.
using your terminal, okay, using
Mm.
commands,
Okay,
what you
sir.
have to do,
Mm.
first you have to, the normal way that I showed you in our basic classes, right?
Mm.
Java is
Mm.
the code to
Yes.
run a Java code. If it's a C++ code, C sharp code, it will be a different command, of course. A Python
Mm.
code will be a different command.
Mm.
For Java, first,
Mm.
if you want to compile the code,
Mm.
you have to give Java, which means Java compiler. And then you need to write the name of the class, right? So we compile this. See, it has
Yes.
compiled
Mm.
successfully. Now we simply run this
Mm.
using Java.
Mm.
Okay.
Yes.
See, we get
Mm.
100. This is
Mm.
another way to run your code. If you're writing, you can simply copy this code, paste it in a notepad, save it in some
Mm.
file using plus
Mm.
one.java. If you save
Mm.
this and if you run from your terminal, that will also work.
Okay. Ha.
Clear? We already showed
Yes,
that
sir.
in our basic classes.
Mm.
We discussed about it.
Mm. Yes, sir.
Clear?
Yes,
Fantastic.
sir. Clear.
Did you understand
Mm.
the problem?
Yes, sir. I understood.
Fantastic.
Yeah.
Fantastic. Good
Mm.
to see that
Mm.
you have made a huge progress, Vandana, in terms of
Mm.
understanding in day one, and
Mm.
specifically when you came from a
Mm.
non-coding background and the way you are progressing, it's immense. So keep up the
Mm.
good work and
Mm.
thank you so much.
Yes, sir. Yeah.
For
Thank
studying
you.
so hard.
Yeah.
Okay.
Mm.
So what I'll do is I will stop my screen share. I will stop the recording first. So let me see.
Okay, sir.
Uh,